So for today, I have attempted 3 LeetCode problems. I have successfully done 2 of them. One of them I was not able to solve, but now I'm going to be going for my 4th LeetCode attempt. So let's try this one. I'm going to do a medium. So the previous 3 questions were all easies. I'm going to try this medium. So flatten binary tree to linked list. Let's see if I can do it. Okay. Minimize me, and let's get started. Do not return anything, modify root in place. Okay, whatever. 114, flatten binary tree to linked list. All right, given the root of a binary tree, flatten the tree into a linked list. Yeah, the linked list should use the same tree node class where the right child pointer points to the next node in the list and the left child pointer is always null. Okay? So we're going to have the exact same structure where there's a node, and this node contains both a left and a right, but the left is always going to be null, and the right is going to point to the next element. Okay. The linked list should be in the same order as a pre-order traversal of the binary tree. Okay, and now if I'm remembering correctly, pre-order is when you process the node immediately when you arrive there. So, for this one, it would be 1, and I immediately process it. Okay, there it is. And then I recurse down left, and I arrive at 2 and immediately process it. Then I come to 3 and immediately process it. Then no more that I can process, so I have to come up, and then I go to 4 and immediately process it. Then nothing else for me to do, so I come up. Nothing else for me to do, so I come up. Then I traverse right, immediately process it, right there. Then nothing for me to do on the left, so then I recurse down and immediately process it. Okay, so do not return anything, modify root in place. Okay, so that actually, I think, does make it a little bit more difficult. So it says, follow up, can you flatten the tree in place? But the comment says to do it in place. So I'm trying to figure out, do I have to do it in place or not? Because follow up implies that you don't actually have to do it this way, but if you want to stretch yourself, you can do it in place and use O of 1 memory complexity. Okay, so thinking about how to solve this, obviously I can do a normal traversal. So I pass down the left, and each time I come down, I process that node, I just copy it over and create a right, and just each time I append the right. But that's not in place. So I want to take this 1, and I need to modify its right value, but I need to change its right value to be its left value. I'm thinking if I swap this, So the problem that I'm coming up against right now is if I come at this root node, I need to process this node here as this node's right child, as we see here. But if I change this to be right, it's going to overwrite this node here. And so I'm going to lose all of this data. I can't just say, oh, root dot right equals 2. You can't do that. So I'm thinking possibly what I'm going to have to do is somehow swap the 2. So I change this value left, this value's left, and to be this value's right. Does that help me? So now the 2 is in place correctly. But then, so the 2 is in place. And then this value is over here. So eventually I will need to take this 5, which is now right here, and it will have to be processed after I come back up. I do not necessarily like this because I'm going to be changing the tree while I am traversing the tree, which I've never tried doing that. Seems very prone to error. So if I do something like return none, if I do something like this, where I take the node, so if not node, return, okay. So that's the case that we have no nodes in this list. We just return because there's nothing to flatten. So now I want to rearrange the left and the right. So node dot left temp equals node dot left. Okay. Node dot left equals node dot right. Node dot what do I want? Node dot right equals temp. So I swapped those two. Then what do I want to do? This 2 is here. So this one is done. Now I want to come down here to 2. Okay, so I want to recurse on the right one now, because the right is 2. So I want to flatten node dot right. So I swap this over here, so 2, and then 2 is here, and now I come back up, and now I swap 2's left and 2's right, so now 3, so it's going to be 1, 2, 3, that's correct, 1, 2, 3, it comes all the way down here, and then I will attempt to pass in its children, but that's not going to work because it will hit this base case. So then I'm going to pop back up to 2, and then 2, I then come down here. So I feel like I'm stuck again. I start here, I can get here, okay, but now I need to change this node to have a right value of this node. How do I get from this node, how do I get access so when I'm inside of this node, I need to get access to this node's child. And then when I am here, I need to get this node's child. And then I can come down here. So is there any at all way for me to access what I need? 1, 2, I'm trying to think if there is a way for me to possibly can I pass in a separate parameter to the traverse function? Like if I had something like this, like def traverse node, and then previous right node, something like that, where under which condition would I use this? So as I'm coming down here, I hit this node, and then I need to, maybe I can keep traversing, but when I kick back up, I take this value, no, I take this value and I keep track of it, I hold on to it, and then I come down here and then I need to immediately process that. Traverse left and right. And so I thought I was onto something. You know, I hit two LeetCodes that I was able to pretty easily, not easily, but I was able to work it through, figure out how to do it, and successfully solve the problem, both of which were easy problems. Then I decided, okay, I'm going to try a medium of the same topic that's depth first search. And now I'm just, once again, very much struggling. So how do I even, well, the linked list should use the same tree node class. Yeah, fine. The linked list should be in the same order as pre-order traversal. The problem really is the fact that when I'm flipping all these things around, I'm losing track of what was where. And then when I'm coming back up, I'm also losing track of the value that I need to append its right child, where so I'll keep going right. Swap them. I'll keep going right, and I don't need to change anything. At that point, it's correct. And then once I go left, then I know that I need to change this value to have this one's. So I need to swap them again. So this one, let's say that it had more. I would have to swap. It's going to have a right and a left. If I swap them, I now need to append this one over there. So I'm going to lose. Now I have three things that I need to keep track of. I can't go down that recursive call because I'm going to lose track of it. Possibly. The other thing that I'm thinking is, what if I go down this path? Once I hit something that I need to change, I keep track of this value, come up here, come down here, and then I keep going down until I hit something. No, that wouldn't work. It wouldn't work because I'm not changing this value. I was thinking about possibly I go down here and then as I'm popping up, then I change the values as I pop up. But that's not going to work because I need to be doing this for value here. I'm not going to be changing these children of 4. I need to do it immediately when I get to 4. So man, I was really hoping to be able to solve a medium, but looks like I have no idea what methodology I can use to solve this one. I think I'm going to have to go and look at Copilot and try to perform the investigation, figure out what I didn't understand, look at the algorithm, try to work on the algorithm. Okay. Okay. What if I do can you explain the methodology but not show the code? So I'm going to see if I can just do the methodology, or look at the methodology and then implement the code from that. Okay, so to flatten a binary tree to a linked list in place, here's a general methodology you can follow. You can use a pre-order traversal, root, left, right, to visit all the nodes in the tree. As you traverse, you need to rewire the connections between nodes to transform the tree into linked list, maintaining the order. The flattened tree should follow the pre-order traversal. This means the root node should be the first node in the linked list, followed by the left subtree and then the right subtree. Yes? Rewiring the nodes. For each node, you need to move its left child to be its right child's position. Yeah? Connect the original right child to the end of the newly formed right tree. Ensure that after rewiring there are no left children remaining in the tree, i.e. all the left pointers should be null. So I don't understand that these points. Handling the next nodes, using a pointer to keep track of the current node being processed, move the pointer along the right child to process each node sequentially. The transformation should be done in place, meaning you should not use extra memory. Instead, adjust the pointers of the adjusting nodes. Okay. Show the code. So we're going to investigate like how it works and why it works. And I hate how it doesn't actually let me copy and paste unless I do it like this. So now I need to go and so flatten. Now this is gone. Def flatten. Flatten tree. Okay, so like this, and then tab that over, see if it works, and then investigate. Okay, so it worked. Now it's time to actually investigate the code, see why it worked. Okay. So pointer to keep track of the previous node in the traversal. Okay, so non-local previous. Now, I guess this actually answers one of the questions that I had in my previous videos. I was talking about the scope of variables. So from a function within a function, how do you have this value accessible? The way that I did it was I just did like self.previous, and that solves it because it makes that variable a member variable of this solution class. But the way that they did it was non-local. They used the non-local keyword, and I guess that allows you to keep this variable, the memory of the variable, intact in a separate function. So if not node, return. Okay, so that is the case where we don't have a node and we just want to return because there's nothing to actually process. Okay, so flatten the right subtree. Flatten tree. So we go right all the way down, okay, to this 6. So I'm at 6, and then I try to go right, I try to go left, and nope. So here's 6. Then I go to node.right equals previous. Previous, which is null. And then node.left, which is null, is null. So okay, that conforms to this That conforms to it. Yeah, that makes sense. Then I do previous equals node. So previous is now equal to 6. Okay, then I pop up, and now I'm at 5. And now 5 attempts to go left, but it can't. So then it sets node dot right equal to 6, because that was previous. I see. So that's how they kind of kept track of that variable. And then the left is going to be null, and then now 5 is the previous. Then I come up here, and then now I just went right, so now I'm going left. So now I go left, and then I go right. So now 4, I see. So now 4 is going to be processed. And so then we come here, node.right equals previous, and previous was 5. Yep. And then the left is none. So I understand how this solution works, but I don't think I could have ever come up with this solution on my own. I feel like, as I've said many times before in previous videos, I'm not going to give up. I'm going to keep going. I will not stop. I'm going to keep pushing through. But man, LeetCode can be so demoralizing. Just failure after failure after failure, and then you're just left thinking like, I feel so dumb. I don't know how to do it. I don't know. I dislike that. Like, how long do I need to study this to be able to look at this and just be like, oh yeah, I know how to do this? Like, just to come up with this off the top of my head. I'm how would I have come up with this off the top of my head? Is there like a methodology of thinking through the problem that I'm missing? Because I felt like maybe I was on the right track when I was going through and kind of like diagramming it out, but I just didn't capture it. I'm not sure. I don't think that my method... If it's a problem that... I'm of two minds right now. The first one says just get as much exposure to as many problems as you can, kind of like memorizing each problem. Just memorize how to do it. Try to understand it as much as you can. Memorize it. And if you memorize enough and you understand enough, eventually you'll be able to kind of see similarities. That's one mind. The other one is possibly I need to go back and really investigate and consider how I am thinking about solving questions. That really is kind of like my dilemma right now. Do I need to go and try to figure out how to solve questions better, or do I just need more exposure to these questions and eventually I will start to understand them more? I don't know. I guess what I'm going to do is both. I'm going to try to take time, like when I'm getting ready to sleep, I'm going to be going through like, okay, how would I go about solving the question? And going to be, I'll watch YouTube videos maybe about how to solve questions effectively. When I watch other people try to go, and that's one of the problems with a lot of LeetCode videos is when they're doing problems, it's problems that the person already knows how to solve it, and they're just bragging about how smart they are and just showing you how to do it and maybe explaining like why the solution works, but they're not problem solving. So it's kind of difficult to see the process of someone looking at a problem for the first time and trying to understand it, which is another reason why I kind of want to do these videos, is because eventually I hope I will become better and better, and then I'll be able to showcase that process of learning and then going through new problems and how do you solve it? What are the methodologies? So that's one thing that I'm going to be doing, is going through and trying to think about how to more effectively tackle problem solving. And number two, I'm going to just keep making these videos rapid fire, as many problems as I can. If I encounter something like this problem that I don't understand, okay, look at the answer, try to force myself to go through it, understand how it's working, why it's working, and then actually, hold on, let me just kind of like, there's a reset, right? Let me just reset. I should be able to just reset it without looking. Okay, come on. Okay. I should be able to solve this without looking. I just saw the answer. Whoops, I didn't mean to do that. There we go. I should be able to solve it straight out. Not straight out, but I mean, I just saw the answer. I should be able to reinforce this with myself. So, what am I doing? Because I want to get the left pathway, I am going to actually be going right. And I know that the rightmost element in this tree is going to be the very last element. Okay, so, and I know that they had previous equals none. Okay, so def and then traverse node. Okay, so then non-local previous. Okay, so now I'm going to be traversing. What do I want to do? I want to get to the last node of this array here, of this linked list here. So that's going to be right, all the way down. So I want to traverse right. Oh, but I do need to make sure that the node exists. So if not node, return. We're done. If we come here into this function and there is no node, we just return. There's nothing else that needs to be flipped around. Okay, so I want to get to the last element. Now, what do I want to do? I want to change this element from memory. I remember that I did traverse left. I know that that's the answer, but I'm trying to work through it so that I can understand the process. And what am I doing right now? What is my methodology of problem solving? I am looking at the output and trying to figure out how to build this output. So I'm not looking at the input. I'm looking at the output. I see the output, and then I'm trying to work backwards of how to build that output. So I see that this 6 is the last element, and I know its values are null and null. And I see this one, so I traversed right because I know that this value, I know the output is like that. So I got to 6, and now I'm trying to make it such that 5 is going to be, I'm going to connect 5 with 6. So I know that previous is going to have to be equal to 6 somewhere. So previous equals node. Okay. So that comes here. And then I'm going to try to go left. Am I going to try to go left? I have to go left. So I want this value, once I pop up from right, I want this value to go in and be connected to 6, which was previous, right? So that's before I change previous's value. So okay, so this has to happen before I change previous. So what did I just do? I came all the way down to 6. Yeah. Then I tried to traverse right again. That didn't work, so now I'm going to set right equal to the previous, and previous is none, so I have none and then none. And then I save this 6 value. Then I need to pop up to 5. I need to try to traverse. No, I just got done traversing right, so maybe I need to traverse left. Okay. So I need to traverse left. There's nothing. So then I need to set this value, and this value needs to be kept the entire way up to 4 because I'm looking at this 5 and 4. So I know that I need to keep this value, so I tried to traverse left, and now I need to add this one to 6. So I put 5 and 6. So node.right is equal to previous. Node.left is equal to none. Yeah. And then I need to keep track of this 5. Then I pop up here, and then I go left. Wait, what about this 1? Do I add? I don't process the 1 yet because I first go at the very root node, I first go right, all the way right, and then I go all the way left. So, no, it doesn't. So left, then I go left, Now I'm at 2. Then I go right, which is 4 now. And previous is equal to 5 still. So I'm keeping track of that value. And then I connect those. And then I delete this one's left value. And then I keep track of this 4. Then I pop up here and then go left. Keep track of this value I add this 4 here. Delete that. Keep track of this one. Then I come here to 4, or to 2, and then I put 2 as 3 because I kept track of that value. I delete this portion, and then I pop finally back up to 1, and I've saved 2 in previous. Okay, so key learnings. I'm trying to point out explicitly what I learned in this problem, how I became better by looking at this problem. Is first step that I needed to do, I understood what it was asking, but I didn't understand how to do it. I looked at the output and I tried to work backwards from the output. The method, I learned a new tool in traversing trees, which is to keep track of a special, and I'm just going to say special, it could fit your unique purpose. So in this case, special is keeping track of a value. So I just kept this non-local value, and I changed this non-local value after I'm trying to think about how I would have known to put it like this, because this is like a post-order traversal. Maybe it's because I'm going right that I need to swap if I do the left and the right. Or, sorry, because I'm first going right, I now need to do a post-order traversal. Maybe that's how I could have identified that. Okay. So I should actually do this. Traverse. And then root. And then I should run this, make sure that it actually works. Yeah, okay, so I did get that right again. So now moving forward, what I'm going to do is I'm going to think about this problem. I'm going to try to conceptualize it. I'm going to try to visualize it. I'm going to try to just mull over this mull over this answer and how this answer connects to the problem, and then the methodology which I might have gone through, that I might have implemented to be able to think of or come up with the solution. So that's my next steps. If you want to come along in this journey with me, I would love that. Just subscribe, and I'm going to be posting LeetCode videos every single day. Not going to give up, going to keep moving forward. So yeah, subscribe if that's something that you would like. Thank you for watching this video. My name is Timothy Lee Grant, and I will see you in the next video. All right, have a wonderful day, everyone.